Hello, AP Chemistry, and welcome to Solutions. So this sounds very mundane because you're like, okay, well, we did all this basic math last year. We know how to do this math. Well, now you have to be able to tie words to that math and describe how to make a solution properly. So, things to think about. One, you're obviously going to mass out however much you need to mass out, right? Which goes back to what kind of molarity you're trying to make. And here we would have to use one of these, which is referred to as a volumetric flask, right? Volumetric flasks are very important because this whole bottle, right, has one volume measurement. And in this case, it would be 250 milliliters, okay? The unique thing about a volumetric flask is that is known to exactly 2 decimal places, right? Which means that we can add in an approximate 3rd decimal place, which means that this is known to a lot of significant figures, right? Way more than your most, I think we'll stop here. Way more than most things, right? If we were to use a 250 ml graduated cylinder, right, it would only estimate to the 1's place, maybe, right? And then we would have to estimate to the 10th place, maybe. But maybe not even that, right? Because 250 ml starts to be a big graduated cylinder. So these are special pieces of glassware, and they have different ones for different volumes. We could use one for 100 ml, right? We could use a 1000 ml, right? But all of them are made only to measure one specific volume. So if we needed to make 250 mils with a solid, we would put our solid in there, we would add our water, right? We would only add some water, by the way, we would stop here, and we would swirl the flask and swirl, swirl, swirl until it was all dissolved. Then we would top it off to the final volume, right? And then we would cap it and then mix it by inverting multiple times, okay? And that's how we would do it if we were starting from a solid. Now, if we were going to do a dilution instead, right, wherein we had a stock solution, a concentrated stock solution that we were going to then dilute, right, same basic principle, right, we would measure out, right, using another volumetric flask if need be, or a graduated cylinder, depending on the accuracy we're looking for. So we would measure out however much we need of my stock solution, which you can calculate, right? So we would have our stock solution, and we would fill this again, like we would fill it with a little bit of water. We would add in our stock solution, we would swirl, and then we would fill it up, then we would cap it off and invert, okay? Generally, the stock is going to be added to some water, okay? Our concentrated stock is generally going to be added to the water. Because if my stock happens to be a concentrated acid, right, that dilution process does release a significant amount of heat, and we want to make sure that that heat is sort of released on the bottom, whereas the more dense stock is going to sink to the bottom, and so the interface will be here instead of up here, all right? So that's just one of those safety things when we make solutions. Now, after we make a solution, right, let's say we're pretty sure we know the concentration, but we're not 100% sure, one of the things that we can do is to then do a titration, where titration is simply an analytical technique that allows us to obviously analyze, right? And most often is for concentration, right? It's to know about a concentration component. So titration happens in 4 general steps where we have our unknown, okay? So in this case, we have an unknown acid. And not so much an unknown acid, but unknown acid concentration. Like we're not 100% sure what it is, okay? So we're going to add our acid, and we're going to add some indicator. An indicator is just something that changes color when we reach the end point of the titration, where the end point is, right, where the total moles of stuff in here equals the total moles of stuff added, right? And it's generally an acid base. It can be a redox process also, right? Redox is also commonly done via titration. But for our purposes, a lot of the time we are talking about acid base. Okay, so anyway, we have this down here, and oftentimes we'll also add some water, okay? And we'll use water to we'll add our acid, and we'll use some water to rinse down the sides to make sure all the particles of acid are in the bottom here, so we can measure all of them, okay? Next up, we have a burette, and the burette is filled with a standard solution of whatever we're going to use, right? So if that's an acid, we're going to use a standard solution of sodium hydroxide. Standard means I know its exact concentration, okay? So I know its exact concentration. So for example, this might be 1.00 molar NaOH, right? and then I know it to 3 significant figures using my using some other technique, right, that this is a standard solution. So this is my solution of known concentration that I'm going to add to my solution of unknown concentration. So this is known, and this is our unknown. So eventually I'm going to add enough known to figure out to reach the end point, right? There was an initial volume and a final volume, and this is the total volume added, okay, to here to reach the endpoint, where again, the endpoint means that I've completely reacted what was in there, which we'll do a math problem momentarily. So what that means is this is the total volume added. If I know the total volume added and I know its concentration, what can I figure out? Moles. I can figure out the moles added. And then if I know the moles of this added, I can use a mole ratio to get to how many moles were down here. Yes? Very good. And then if I know the initial volume I had down here, and I know the moles in the volume, I can calculate the molarity of my unknown solution. Okay, let's go ahead and do a problem. What is the molarity of an NaOH solution if 48 mils neutralizes this much acid? So what occurs to us to do first? Right, we need an equation. So we know we have NaOH, and it's reacting with sulfuric acid. Hey. And it's going to produce all of this. Yes? Okay. Put a 2 here, and we're done. Now, 48 milliliters of this neutralizes this much of the known, right? So here's my volume and concentration of my known, right? So that's like the stuff that's in the burette. So in this time, we have base in the flask and acid in the burette, okay? So we know that this is how much it takes, so we're going to use our volume. I don't know why I keep doing that. And then we're going to use this, right, 0.144 moles of H2SO4 for every 1 liter of H2SO4. Oh my gosh. Okay. And then we're going to go from here to here. So for every 1 mole of H2SO4, it reacted with 2 moles of NaOH. Yes? So for every 1 mole added of this, it reacted with or neutralized 2 moles of that. Now, molarity is moles per liter, so I'm going to divide it by so my moles of this cancel, my liters of that cancel, and I'm left with moles per liter. Yes? And that would be the math I would do to solve that problem. Yes? Fantastic. Thanks for listening. Be good, and I will see you guys soon. Bye.